can
These
create
wide and
that.
shallow pans can be used to saute, sear, or fry food. Water released from the food during cooking creates that sizzling sound. The
Look,
shape of the pan allows steam to dissipate,
Put your head
giving
in.
food a crispy finish.
here, like that. Look how they
A
create the
good
pan.
non-stick frying
Don't you
pan
wanna
is a
know?
must in the kitchen.
How do you create the pan that you make
A
eggs
frying
on?
pan can be made of any heat-conductive metal, in this case aluminum alloy ingots. They melt the ingots. A robotic ladle scoops up molten aluminum to be used for casting.
Wow.
They use this two-part die to transform liquid aluminum into a frying pan.
Wow, it's a big machine.
The robotic ladle pours the aluminum into the die through a cylindrical port.
Look,
This high-pressure casting produces a very precise shape. After about a minute, an operator takes it out. They cut off the excess using a computerized tool. The table moves as the tool cuts the edge of the pan to specifications. A worker sands the edges and rounds the rim of the pan a little more. They cast pans in several sizes and thicknesses. An employee keeps a detailed inventory of the pans. Next, they put the pans in a sandblasting chamber. The sandblaster cleans off oil and residue. It also roughens up the surface of the pans to prepare them for coating. An employee scrubs off the sand using an abrasive pad. Next, the pans receive their ceramic coating. Each pan spins on a pod as a plasma flame melts 3 different powders onto it. The coating protects the pan from corrosion.
wow, look.
An employee scrubs each pan with an abrasive pad to remove the residue. This time, the frying pans spin slowly as torches heat them to approximately 175 degrees. This preheat preps the pans for the final coatings. They prepare up to 5 proprietary coating formulations for each frying pan model. Each one contains dozens of chemicals and thousands of tiny diamond particles. The diamonds increase durability and heat conductivity. They also make food less likely to stick to the surface of the pan. The final coating contains a non-stick chemical known as PTFE. They spray the different coatings onto the surface. The spinning ensures even coverage as the coatings adhere to the hot pans. Now a primer is applied. It allows the final non-stick coating to bond to the frying pan.
Wow.
At the end of the line, an employee inspects the finish and sprays a little more of the non-stick formula onto the handle fitting. Then the frying pans go through a furnace to bake the coatings onto the pans. An employee checks the finish for bubbles, scratches, or color inconsistencies. Once the pans have cooled, a robot transfers them to a lathe. The lathe spins the pan as a tool shaves off a thin layer of aluminum. This leaves a clean level surface on the bottom of the pan. A suctioning robot moves the frying pan to the next station, where a worker attaches a handle to the pan. An automatic screwdriver secures it.
Wow.
A technician heats one of the frying pans on a cooktop as a mechanical arm rubs the pan thousands of times with a
How
coarse
this
piece
kid
of
created
sandpaper.
it? Don't you want to own your own factory and create stuff and sell them?
There are no scratches, so the entire batch of pans is approved. Thousands of non-stick frying pans are ready to leave the factory and cook up a tasty meal.